Finally, we're going to look at the graphs of tangent and cotangent. So what we want to remember about tangent and cotangent is that they're ratios of sine and cosine. So tangent is the ratio of sine over cosine. And so just like secant and cosecant, there are going to be times that tangent and cotangent are undefined, and we're going to get vertical asymptotes. So for tangent, that happens when cosine equals 0. So what we're going to use as our base graph for tangent is cosine. So when I'm graphing tangent, we'll start with graphing the corresponding cosine graph, and then everywhere on the cosine graph that's a 0, aka a point hitting the midline when we have a vertical translation, becomes an asymptote, so similar to secant. What's different is how I draw my graph from here. So we find our midline, so I'm going to draw that on here. Since this one wasn't translated up or down, it's on our x-axis. We go in between the asymptotes on the midline, and that's going to be the center of each part of my tangent graph. And then positive tangent snakes up. It's sort of cubic-y. Negative tangent snakes down. So through all these, I'm just going to kind of do something like this. The point is actually our point of inflection on these graphs. And that is it. So I'm down here, every 0 or midline point in cosine becomes an asymptote of tangent. And between the asymptotes, the tangent looks like a snake with our point of inflection on the midline. So let's look at a couple examples. So if I do this, first let's factor out that 2. So 2 tangent of 2x minus pi over 2 minus 1. My amplitude is going to be 2. And I'm going to fill this in terms of cosine for this next part. So the same thing as 2 cosine 2x minus pi over 2 minus 1. So my period for cosine would be pi. My phase shift is right pi over 2. Midline is down 1. I emphasize that because when we actually graph tangent, you're going to see something weird happen with my period of tangent compared to everything we've looked at before. So let's graph this cosine function. I'm going to go in terms of pi's over 2. So right pi over 2, down 1, up my amplitude, down my amplitude, and run for my period, which we said is pi. I have room to do 2 of those. I didn't do a very good job of scaling those. Those should be equal. And draw my midline. And our shape is a positive cosine, although it doesn't actually matter for this first part. Like I said, these should be symmetric. I didn't do a great job scaling. All right, so here's my cosine graph. Everywhere that cosine intersects my midline is going to be an asymptote. And then equally between each asymptote on the midline is where I'm going to have my point of inflection for tangent. And then it's going to snake up. So what you'll see with this is it takes less time for tangent to repeat than it does for cosine and the other 4 functions that we've looked at so far. So my default period for tangent and cotangent is pi. So if I want to know my period for this function, I would do pi over the b in my equation, 2. So my period is pi over 2, and I can look at that on my graph that it's taking pi over 2 to repeat. So I'm still going to do my table in terms of sine and cosine, regular 2 pi over b. But if I ask you what the period of tangent would be, it would be pi over 2. It's going to be half of that. So let's look at another example. This one has a lot more going on. So first I'm going to factor out this negative pi. Which leaves me with x minus 3 over 2 plus 1. So honors, what we need to know is that tangent is an odd function. So that negative is going to come outside. Standard, don't worry about that. I would just go ahead and give you this as negative tangent. Don't worry about why that happened. So now let's fill in our table, and we're going to think about doing this as cosine since we're doing tangent. So I've just filled in our table like normal. I see my phase shift is right 1.5, so I'm going to do my scale in terms of halves. And you could do these without reducing your denominators if you want to. All right, so phase shift of right 3 over 2, and then up 1, then up and down my amplitude, which is 1/2, run for my period of 2, so that would be over here, and I'm already going to get 2 periods of tangent because, like we said, it is half the period of cosine. So let's draw my negative cosine. Although, like I said, doesn't actually really matter because what matters is where cosine is hitting my midline. So here we go. And then I can see I could keep going over here. Then I put my point of inflection equally between my vertical asymptotes on my midline. And since positive tangent snakes up, negative tangent slopes down. So once again, the fact that it's positive cosine, negative cosine doesn't actually matter. What matters is my overall shape for tangent. Honors, try to do the analysis page.